Hi, this is Alex from devstories.eu. GitHub Actions, episode 7 of 14. A developer pushes 3 rapid-fire commits to an open pull request in 5 minutes. If your CI server is grinding through 3 redundant test suites, you are burning money. You need a way to tell the system that only the latest code matters, and that is exactly what controlling flow with concurrency handles. By default, GitHub Actions runs triggered workflows in parallel. If you push 5 times, it spins up 5 independent runners. For basic checks, this wastes runner minutes. For deployments, it is actively dangerous. If 2 workflow runs try to deploy to the same staging environment simultaneously, you create a race condition. The older commit might even finish deploying after the newer one, overwriting your updates and leaving your environment in an outdated state. You fix this using the concurrency keyword. You can apply it at the top level of the entire workflow or restrict it to a specific job. The mechanism relies entirely on concurrency groups. A concurrency group is just a string name you define. If 2 runs share the exact same group name, GitHub enforces concurrency limits between them. Many people make the mistake of hard-coding this string. If you set the group name to just the word deploy, then pushing to your testing branch will cancel an active deployment on your main production branch. The group name must be dynamic. You construct it using context variables, like the current branch reference. If you name the group using the pull request number, then concurrency limits apply only to pushes within that specific pull request. Your main branch remains completely unaffected. When a new workflow is triggered, GitHub checks if a run is already active for that concurrency group. If there is, the default behavior is to place the new run in a pending state. It waits in a queue. Here is the key insight. The queue only holds 1 pending job. If a 3rd run is triggered while the first is running and the second is pending, the second run is ejected from the queue. Only the absolute latest run gets to wait. Waiting is safer for deployments, but for pull request testing, waiting still consumes unnecessary time. This is where the cancel in progress setting comes in. It is a Boolean flag you add under your concurrency group definition. When you set cancel in progress to true, you change the behavior from queuing to terminating. Go back to the developer pushing 3 rapid-fire commits. The first push triggers a test suite. 2 minutes later, they push again. Because you set the concurrency group to the branch name and enabled cancel in progress, GitHub sees the new run, instantly terminates the active test suite for the first commit, and starts testing the second commit. When the 3rd push happens a minute later, it terminates the second run and starts the 3rd. The developer still gets the final pass or fail, but you only paid to execute the tests once. Concurrency controls turn your CI pipelines from a reactive system that blindly executes every trigger into a state-aware system that only spends resources on the code that actually matters. Thanks for listening. Happy coding, everyone.